In our previous section, we discussed about the BGP VPN case when we were doing the ingress replication. So using the BGP VPN, we were able to distribute the VTAP to VNI mapping to all the leaf switches, right? So we mentioned at the end of the video that we are going to do a packet walk, but before we start the packet walk, I would like to show you 2-3 more information that should have been discussed, but somehow I forgot. So if I go to any of the switch, if I do a show MAC address table, so you can see that leaf 5 is learning about the MAC address of host 1, right? So 1111 is the MAC address of host 1. It is learning it via leaf 3. You can see that it is mentioned that it is learning this particular information via the NV interface, right? And who is the originator of this particular information? That is leaf 3, which is having the loopback IP of 3333. Another thing that I would like to show you is if I do a show running configuration, we discussed about the RD and RT value, right? So if you look at here, we have this particular section wherein you can configure the RD and RT value for a particular VNI, right? So you can see we have the EVPN, then the VNI, then you need to mention, I will just show you. You need to type EVPN, then you need to say enter, then you need to mention the VNI number, let's say 202020. You need to say L2, then you have to say RD, either you can say auto or you can configure it manually, okay? So we already discussed about the RD auto value, how it is going to pick up this particular RD and RT values, right? So this is how you can configure it manually also. Just type RD and then you can define a value according to your design. Also, likewise, you can configure the route targets. So the route targets also you can either say, let's say route targets both auto, or you can mention the value according to your design. So this is how you can configure the RD and RT value manually. So what else? We can also have a quick look, show BGP, L2 VPN, EVPN, and we can pick up the MAC address of, let's say, host 1. This we already discussed, right? This portion. So I'll again go through this quickly. So at very first, you can see in the bracket, you have number 2. It means that it is a route type 2. Okay, so route type 2 can carry the information of MAC, and it can also carry the information of the IP address. So this particular entry for route type 2, it is carrying only the MAC address. You can see that we have the route type 2. Then you can see here 48 bits, which is the MAC address length, followed by the MAC address. Then in the highlighted portion, it is for the IP address length, but we do as this particular route type 2 entry is not carrying any IP address. So at the length field and the IP address field, there is all 0, nothing is there. And this particular, so the route types are counted by the bits. So for route type 2 with MAC address only entry, it is having /216. Okay, if you also have the IP address included in route type 2, then after slash you will see 272. Okay, there will be extra 52 bits, which will be your 32 bits will be your IP address, and 24 bits will be your layer 3 VNI. So in the case, in that particular case, wherein your route type 2 will carry IP address also, you will see /272. We'll see it in our future videos. Okay. So I think we discussed most of this stuff. Now I would like to do a packet walk so that you'll be able to understand how the flow is working between different hosts. Okay, let's take an example. Let's try to ping from host 1 to host 5. Okay, let me delete these so that you'll be having some space. Okay, so now we have host 1 and host 5. So before there is no communication, you can say that host 1, it does not know about the MAC of 10.1.1.5, right? So host 1 is going to send an ARP request to find out what is the MAC address of 10.1.1.5, right? So the source IP will be 10.1.1.3. I'm just simply putting 10.3, okay? Then we'll be having the destination IP. Destination IP will be 10.1.1.5. The source MAC will be the MAC address of host 1, 111. Destination MAC will be all zeros, right? Then this particular ARP request at layer 2, so 2 more information will be added, right? That will be your source MAC, which will be your this one, and OLF, right? So at layer 2, ARPA is going to put this information, right? Source MAC will be 11111. This is the host 1, and as this is a broadcast frame, it is going to put OLF. And now this particular information, let me pick it up. It will be sent to leaf 3, right? So leaf 3 is going to do a basic function that it is going to save the entry that MAC 111. It is learning from Ethernet 1/3, right? This particular information leaf 3 is going to learn. First thing, now because it is a broadcast frame, right? And leaf 3 received, as you know, that this is in VLAN 10, right? On both sides, this particular interfaces are in VLAN 10, and they are part of VNI 10.10.10, right? I'm also mentioning it here, VNI 10.10.10. So leaf 3 received a broadcast frame into VLAN 10, or you can say in VNI 10.10.10. As we know that now in VXLAN, the broadcast domains are the VNIs, right? Leaf 3 is already having the mapping of, or you can say that the replication list, leaf 3 has already been received from leaf 4 and leaf 5. So leaf 3 already knows that if it needs to send the bump traffic, or if it received any bump traffic in for VNI 10.10.10, it needs to send the that particular bump traffic to leaf 4 and leaf 5. So now leaf 3 is going to create 2 copies, one for leaf 4 and one for leaf 5. So I'll show you just for leaf 5. Okay. So this particular payload is received, right, by leaf 3. Now leaf 3 is going to add extra information. Let me select it. Okay. So this particular information was removed, right, by so leaf 3 is going to put some information like this. Okay. I'm just speaking. You can write it down maybe in your notebook. If I type I, it means inner. I will say S means source, M in MAC. Inner source MAC address it is going to put. So that will be the MAC address of host 1. Then it will put inner destination MAC. Okay, so inner destination MAC will be OLF because it is a broadcast frame. This inner MAC header or this inner source MAC and destination MAC is very, very important. I will tell you when we'll receive this particular frame on the destination side. Now, what other information it is going to put? Let's see. So it is going to add more information, something like this. So it will add the VXLAN header, or you can say it will add the VNI number. Okay, so what is the layer 2 VNI? So it will add 10, 10, 10. Right, this is the layer 2 VNI for VLAN 10, correct? So this is the VXLAN related information. Now it is going to add the UDP header. Right, UDP we already discussed is used for ECMP, right? It will add the UDP header. So after the UDP header, it will add the source VTAP address. Okay, what is the source VTAP address? The source VTAP address is its own VTAP address, which is 333. Now it is going to add the destination VTAP address. So one copy it will create for leaf 4 and another copy it is going to create for leaf 5. So let's say it is creating it for leaf 5. So destination VTAP address will be 555. Then it will create or it will add two more things. So now we have the outer MAC header. So in the outer source MAC, see, now it will follow this simple layer 3 device process. Let's say if you have a router, so before a router sends the information on the particular layer 3 link, it is going to modify the, or it is going to use the source MAC as the outgoing interface MAC and the destination MAC as the next hop MAC. So its source MAC address will be 3131, which is the Ethernet 1x1 interface of leaf 3, and the destination MAC will be 0011, which is the MAC address of spine 1 interface, which is connected to leaf 3, right? So a few information I can tell you, like in the UDP header, there will be source port that will be random. It will choose it randomly to perform ECMP, and the destination port will always be 4789, I think. This is for VXLAN. Okay. This is the packet that spine, the leaf 3 is going to create. So again, I'll tell you quickly. So it received this particular payload, right? This is the payload it received. So it received the ARP request. From the ARP request, it is going to put this is your, you can say, inner MAC header. In the inner MAC address, there are two fields: inner source MAC, which will be the MAC address of your host 1111. Destination MAC, inner destination MAC will be OLF. It is a broadcast frame, or it's the bump traffic. Then you have here, you can see you have the VXLAN header. It is going to put the VNI information, which is 10.10.10. We have the UDP header. Then you have the source tap address, okay, or source VTAP address, which is its own VTAP address. Then you have the destination VTAP. Then you have the outer source MAC, and you have the outer destination MAC. So outer source and destination MAC are nothing but the exit interface MAC addresses. The simple layer 3 devices concept. Okay, nothing new. So this particular packet will go to spine 1. See this, you can see that if the outer destination MAC is not the MAC address of spine 1 interface, so at layer 2 it is so at layer 2 this particular frame will not be accepted, and spine 1 is going to drop this packet. It is simple OSI model, right? Nothing is fancy or new in that. So spine is going to receive this particular frame. Now it will check for the destination VTAP. So the destination VTAP is 555. So now spine is going to send this particular frame to 555. And again, before sending this particular information to 555, it is again doing the same thing as a layer 3 device. It is going to put the outer, so it will remove the outer source MAC 3131. It will put the MAC address of its own interface, which is connected to leaf 5, that is 0013. Let me clean it. So spine is going to remove this particular outer source MAC. It will put its own interface MAC 0013, and in the destination MAC, it will put the next hop IP, which is the IP address of, the MAC address of leaf 5 interface Ethernet 1/1, which is 5151. So as soon as 5151 MAC address is in the destination, leaf 5 at layer 2 is going to receive this particular frame. And you can see that the destination VTAP is 555. So this is leaf 5 VTAP address, source VTAP. Now leaf 5 knows that this particular information is sent from leaf 3, right? And also it has the, it belongs to VNI 10.10.10, right? What is the source MAC or the inner MAC header? In the inner MAC address, it has the source MAC as 1111. Now leaf 5 has some information that MAC 1111 is, it belongs to VNI what, 10.10.10, and it is behind which VTAP 333, right? So now leaf 5 can store this particular information, right? Also, now looking at the inner destination MAC, leaf 5 is going to take the decision what to do with this particular information. So now you can see that inner MAC header is very, very important, right? Because if there is no inner MAC header, then leaf 5 will not be able to decide what to do with this particular information, right? Yes, leaf 5, obviously it received this particular information because the destination VTAP was 555, but what to do with the payload? Because leaf 5 itself is not the destination, right? The actual destination is something else. So now leaf 5 needs to decide what to do with the frame. So it is going to look at the inner destination MAC, which is OLF. Now it will get to know that, okay, this is a broadcast frame, and I received it in, I received this particular information for VXLAN or VNI 10.10.10. So leaf 5 is going to flood the rest of the ARP request. It will remove the inner MAC header and everything. So it will send the particular ARP request to to all the ports which belongs to VLAN 10. In our case, it is going to send this particular information to host 5 here, right? Now host 5 is going to reply back, right? With now the same flow will be there. So host 5 is going to reply with source IP now will be 10.5, destination IP will be 10.3, source MAC will be 555, destination MAC will be destination MAC will be 1111, which already was there into the ARP request. Now leaf 5 is going to receive it. Now leaf 5 is going to check this particular information because ARP reply is a unicast packet, right? It is not bump traffic. So leaf 5 already knows about the MAC address 11111 that it is behind VTAP 333. So now it can receive this payload. It will put some extra information. So the inner source will be now this time the inner source MAC will be 5555. Inner destination MAC will be host 1 MAC address, right? Then what else? Let me put it like this. Then it will put the VNI. Then it is going to put the UDP. It is going to put the UDP header, right? Then the source and destination tab, and then the outer source MAC and destination MAC. Let me quickly configure it here. So after the inner source and destination MAC, it will put the VXLAN, which is the L2 VNI, which is 10.10.10.10. Then we have the UDP header, right? You already knows about it. Then it will put the source and destination tab. Source tab will be 5555. Destination tab will be 3333, right? Now outer source MAC will be the exit interface MAC, which is in case of leaf 5 we have 5151. Outer destination MAC will be spine 1 interface MAC, which is connected to leaf 5, which is 0013. Simple layer 3 logic. And now once spine 1 receives this particular information, it is going to do the same action. It is going to remove the outer source MAC and destination MAC. It already has the information about 3333, right? So it can send this particular information to leaf 3 by changing the, it is only going to change the outer source and destination MAC. Outer source MAC will be 0011, which is spine 1 MAC, and outer destination MAC will be 3131, which will be the leaf 3 interface Ethernet 1x1 MAC, right? Leaf 3 is going to remove all the VXLAN related information, and it will send the particular ARP reply to host 1. Also now leaf 3 knows about 5555, that it is a part of VNI 10.10.10, and it this particular information is sent from this 5555. Okay. So now you can see that we have information, proper information now. Host 1 and host 5, they can ping properly. Okay. Also, there is one more catch, or I would say that there is one more thing that BGP EVPN is going to do, that as soon as you see that when there was the ARP request from host 1, leaf 3 received that particular ARP request and it knows about the MAC address of host 1. Okay. So as soon as leaf 3 get to know about this particular information, this particular information will be shared with the BGP EVPN as a route type 2. That information you already seen, right? If I think I was there. If I do a show here, you can see that, or you can say show BGP L2 VPN, EVPN, let's say for VNI 10.10.10. You can see, or just say this. You can say that we have in the BGP EVPN control plane, we have the information about route type 3. Wait a second, I think we do not have the information about endpoints. I think maybe the ARP is timed out. Let me ping it again. Ping 10.1.1.5. Now I will run this command again. Now you can see that as soon as we are communicating between the host into the BGP EVPN control plane, we have a route type 2, right? So as soon as the leaf switch, they received some information. Let's say leaf 3 received the ARP request and it now knows about the host 1 MAC address. It is going to share this particular information into the BGP EVPN as a route type 2, and spine is then it is going to share this particular information to all the connected clients. So leaf 4 and leaf 5 are going to receive the particular information about the MAC address of 1111 as a route type 2 also. Okay. So this is how the packet flow works from host 1 and host 5. So also, as I mentioned, that in case of ingress replication, it is going to create one copy for leaf 4 also, right? So leaf 4 is also going to receive this particular information. It is also going to take the same action as leaf 5. It is going to remove all the VXLAN related information, and it is going to flood this remaining information to the host that belongs to VLAN 10. Okay. So, and because there is no host that is having the IP address 10.1.1.5, so leaf 4 is not going to get any response from the downside. Okay. So this is how the packet flow works from source to destination in case of BGP EVPN and BGP EVPN with ingress replication. Okay. So I think now it is clear. So the ARP communication is working from source to destination, and once host 1 and host 2, they knows about their MAC address. Now directly the ICMP can travel from host 1 and host 5 and directly looking at, because now in the next packet, the destination MAC will be the MAC address of host 5. So leaf 3 is going to check its VNI table wherein it can see the information that 555 is reachable via 5555. So it is going to put all this information into VXLAN. It is going to send it to spine. Spine will send it to leaf 5. As simple as that. I hope the packet flow is clear, and we'll keep on doing the packet flow in our upcoming videos also, wherein we'll do multicast and the BGP, VPN, symmetrical IRB and all that. So this was some basic packet flow in case of BGP VPN using the ingress replication. Thanks.